This animation demonstrates the Earth learning idea, did the continents move for you? This involves plotting the movement of a continent using an apparent polar wandering curve. As you can see in the animation, the magnetic North Pole and a large continent have been drawn. This is the position of the continent about 500 million years ago in Cambrian times. How do we know that? Well, that should be clear at the end of this animation. At this time on the continent, there were volcanic eruptions, or magma pushing its way upwards, at the two places marked with red crosses. When the magma, or lava if it came to the surface, cooled down, forming igneous rocks, the magnetic minerals contained in them were magnetized in the direction of the Earth's magnetic field at the time. Ancient magnetism is called Paleomagnetism, and the orientation of the continent at the time of the formation of these rocks with magnetic minerals is known. Sometimes this magnetism is called frozen or remanent magnetisation. Of course, there is an Earth learning idea which explains this in more detail. You can find it by using the search engine on the website. But continents move, and this one slowly moved north and to the east. It moved at about the speed that your fingernails grow. About 100 million years ago in Cretaceous times, it was in the position you see now. Once again there were volcanic eruptions, or magma pushing its way upwards, at the places marked by blue crosses. The lava or magma cooled to form igneous rocks, which again contained iron minerals, which became magnetized in the direction of the Earth's magnetic field. Over the next 100 million years, the continent again moved slowly north until it reached its present position. Once again there were volcanic eruptions or magma pushing its way upwards at two places marked by yellow crosses, and once again the lava or magma cooled to form igneous rocks with iron minerals which became magnetized in the direction of the Earth's magnetic field. You can now see two lines from the red crosses joining at the Cambrian magnetic North Pole. Now two lines from the blue crosses joining at the Cretaceous magnetic North Pole. The three poles are now joined, giving what is called a polar wandering curve. This curve, based on the evidence from the frozen or remanent magnetization of the rocks, appears to show that the magnetic pole has moved. But as more detailed information was gathered from different continents, it became clear that the pole has never moved more than a few hundred kilometers from the geographic pole, and it was the continents which had moved across the surface of the Earth. So how is this evidence for continental drift? Well, if you take away the wandering polar curve and move the continent until the two blue lines join the magnetic pole, you have the position or latitude of the continent in Cretaceous times. You can do the same with the red lines, and now you have the continent's latitude in Cambrian times. Apparent polar wandering curves are regarded as excellent evidence for continental drift or plate tectonic movement. Lots of other pieces of evidence for the plate tectonic theory can be found in Earth learning idea, video clips and activities. Questions that are often asked. What happens when the magnetic pole flips and magnetic north is at the South Pole? This doesn't affect the magnetized direction of the iron minerals. They will still be aligned with the direction of the Earth's magnetic field. Needless to say, there is an Earth learning idea about magnetic reversals. Use the search engine to find it. This evidence gives a reasonably accurate latitude for the continent, but how do you work out the longitude? This is not easy, but can be done roughly by knowing which way the continents moved and their positions relative to one another.